Note in an infinite cosmic symphony that has no beginning. End, no end. String theory, perhaps the most ambitious attempt to unify all the forces of nature into a single mathematical framework, suggests that reality consists of vibrating strings of energy existing in 11 dimensions, most of which are curled up so tightly that we can't perceive them directly. In this view, every particle in the universe is actually a string vibrating at a specific frequency, like notes played on a cosmic piano. Matter, energy, space, and time are all different harmonics of the same fundamental vibration. Different ways that strings can oscillate through the hidden dimensions of reality. But string theory comes with its own bizarre implications. If reality has 11 dimensions, then every three-dimensional object we see is actually a shadow cast by higher dimensional structures we can't directly observe. Your body exists in 11 dimensions, but your senses can only perceive 3 of them plus time. The real you, the complete you, extends through dimensions that remain forever hidden from direct experience. Like a hyperdimensional being trying to understand itself through the limited perspective of a flatlander, the extra dimensions of string theory might provide escape routes from the apparent finality of cosmic endings. If our three-dimensional universe faces heat, death, or collapse, perhaps consciousness could migrate into higher dimensions, finding new forms of existence in spaces we can't currently imagine. Death might not be termination, but transformation. A phase transition from three-dimensional existence to something more complex, more complete, more real than our current shadow existence allows us to comprehend. Loop quantum gravity offers a different perspective on the fundamental structure of space-time, suggesting that space and time themselves are quantized, composed of discrete indivisible units, rather than smooth continuous manifolds. In this view, space-time has a granular structure at the smallest scales, like a cosmic pixelation, that becomes apparent only when you zoom in far enough. The smooth space-time of general relativity emerges from this quantum foam the same way that the smooth surface of water emerges from the chaotic dance of individual molecules. If space-time is quantized, then the singularities that plague classical physics might not exist at all. Instead of infinite density and zero volume collapsing, matter might reach a minimum size and maximum density before bouncing back in a cosmic rebound that creates new space and time. The Big Bang might have been a big bounce, the moment when a previous universe reached maximum compression and rebounded into expansion, suggesting that cosmic history consists of endless cycles of expansion and contraction, creation and destruction, death and rebirth. This cyclical model of cosmology has ancient roots in Hindu and Buddhist philosophy, but modern physics provides new mathematical foundations for old intuitions about the eternal nature of existence. If the universe bounces rather than ending in singularities, then cosmic death becomes cosmic rebirth. The end of one reality becomes the beginning of another. And the ultimate fate of the universe transforms from final termination to endless renewal. But even eternal cycling raises profound questions about identity and continuity. If the universe bounces back from collapse, is the new universe that emerges the same universe or a different one? Do the patterns of matter and energy that constitute consciousness survive the bounce? Or does each cycle begin with a completely fresh start? Would you be you in the next universe? Or would you be someone else entirely? A different arrangement of the same fundamental elements, following similar but not identical patterns of development. The grandfather paradox of time travel reveals the deep logical contradictions that lurk within,